Okay, there's typically a better way to solve these problems. And so we're going to kind of talk about that also. So there's 3 methods. They are graphing. So write this down. Graphing, elimination, and then substitution. Okay. The first one, this one looks like it's going to be easiest to be graphed. Does anybody know why it's going to be easiest to be graphed on that one? Right. It's already in slope-intercept form. So like on this first one, my y-intercept, or my b value, is this 3. That one right there. My slope is negative 5/3. It's the number in front of the x. Okay? So what I'm going to do is I'm going to come over here to this graph. I'm going to start graphing. I have a y-intercept of 3. So 1, 2, 3, and I put a point there. My slope tells me to go down 5 because it's negative 5 over 3. So I'm going to go down 5 and positive 3. Typically, we want more than 2 points on a graph to make it a little more accurate, but I can't fit more than 2 points on this one. I'm going to connect that with a straight edge. So with a phone, with a sheet of paper, something that's straight, so I can get the most accurate line possible. Okay? The next one, I have a y-intercept or a b value of negative 3. And I have a slope, or m, of 1/3. So I'm going to graph that. My y-intercept is down 3. But my slope tells me go up 1 and over 3. 1, 2, 3. We should see the point of intersection then. They intersect at a point that's on both of them. Someone yell out, what is that point of intersection? What, comma, what? Awesome. Who was that? Annalise, was that you? Awesome. 3, negative 2. Thank you. So that is what you're doing on graphing systems of linear equations. You're seeing where they truly cross on the graph, okay? Next one, number 2. Okay, so we've done graphing. We still have elimination and we have substitution. Looking at the way number 2 is set up, does anybody see the easier method to use on this between elimination and substitution? Anyone, anyone, anyone? Okay, we are going to use substitution on this because y is already by itself. So what y equals, I put into parentheses. I'm going to take that, I'm going to plug it in for y. Everything that I put in parentheses, I'm going to plug in for y. So I'm going to take out y, but I'm going to put in x minus 1. So I'm going to rewrite this top equation as negative 4x plus 3. Take out my y and put in x minus 1, parentheses, set it equal to negative 2. Any questions on what I did there, guys? Okay. Who knows what my next step is? Someone take a guess. If it's wrong, it's wrong. I don't care. I just want you guys to talk and work through this. What do I do? Yes, yes, yes. Very good. I'm going to distribute this 3. So I'm going to bring down this negative 4x, but now I'm going to distribute the 3. So I'm going to do 3 times x, which is plus 3x. And I'm going to do 3 times negative 1, which is negative 3. I set that equal to negative 2. Who knows the next step? To start solving for x is our goal. Yes. Combine like terms on the same side. So you just put them together. Since they're on the same side of the equal sign, I put them together. So negative 4x's and 3x's together make negative 1x. So I get negative 1x minus 3 equals negative 2. What would you do now to start solving for x? I'm going to add 3 on both sides. Perfect. Not negative, but just 3. And that's exactly correct. Negative 3 plus 3 cancels because it goes to 0, so I don't need to show that. So I'm left with negative 1x equals negative 2 plus 3 is just 1. Do I want a negative x or a positive x? I want positive. So what I'm going to do to get that x to positive is I'm going to divide by the negative 1 because I don't want it negative. That cancels on that side. So I get x equals, what's 1 divided by negative 1? There we go. So we have negative 1 as part of my answer. What I saw on one of the annotation worksheets that you guys turned in is that you guys would stop at that point. We found x, but is that a point on a coordinate grid at that instance? No, because we have to have the y that goes with it. The easiest way to find the y is take your x, plug it in for x in either equation, but there's an easier equation. This one will be easier. So I'm going to say y equals, instead of x, I'm going to put in my negative 1 that we know x equals. Negative 1 minus 1. What's negative 1 minus 1? I'm here at 0, go back negative 1, go back another 1. Where am I at? Yep. So y is negative 2. We doing okay, guys? All right. Which method does that leave for the third one? Elimination. Yep. And elimination is where you have your x's on top of your x's, your y's on top of your y's, your equal on top of your equal, and your numbers on top of your numbers, just like I do here. And your goal is to get rid of either your x's or your y's. Who sees what I can get rid of right away on this one? Because we're going to add these essentially. Yeah. What's 2x plus a negative 2x? Well, if I have 2 apples and then I take away 2 apples, do I still have an apple? I have 0. So that is gone. What's 3y's plus a y? 4y's. Equals, what's 20 plus 4? 24. What do you do to solve for y? Divide by 4. Excellent. So I get y equals 6. Are we done? No. What do I need to do now? Solve for x. I think I heard someone whisper that. How do I solve for x? Plug it into one of the equations. Perfect. Does it matter which one I choose, guys? No, I'm going to go with the bottom one. The bottom one looks a little shorter, so that looks a little easier to me. Negative 2x plus, instead of the y, I'm going to put in that 6, equals 4. Subtract 6 from both sides. That's gone. So I get negative 2x equals, what's 4 minus 6? Perfect. How do you get x by itself now? Divide by what? What's negative 2 divided by negative 2? So my point is at x comma y, so 1 comma 6. How are we doing? Doing okay? All right. So that was kind of a warm-up to get you back on track on what we've been doing. Okay. I want you to go to the next page. And so, Annalise and Michael, I gave you this page also. What I want for you to do right now is I want you to try number 1 completely on your own right now. That is a graphing one. So if you're confused on what you do, flip back to the previous page so you can see what we did on number 1 on the previous page to help you with this one. So on your own, we will go over this, but I need for you to attempt and try it. Okay, so go ahead and do number 1. The first line on this one is a y-intercept of 2. So point here at y-intercept of 2. What's my slope here, guys? What's in front of the x? 1. So it means I go up. Oh, I put that in the wrong spot. I'm sorry. I go up 1 over 1, up 1 over 1, up 1 over 1. And I keep doing that. And so now I'm going to connect the points. Okay. Then the next one. What's my y-intercept on the second one? Yep, so I'm going to go down 2. My slope is up 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Oh, there's my point of intersection. So just graphing the lines is not enough, though. You actually have to tell me what that point is at. So what is that point at that they cross right there? It should be on your paper. It's up on my paper. What's your x value and your y value? Awesome. Thank you. 2, 4. Perfect. Okay. Go down to number 4. Number 4 down below. Which method do they want you to use here? Substitution. I want you to try substitution right now, okay? So go ahead and do substitution. First thing I did is I put what y equals on the top in parentheses. That is what I'm going to plug in for y down here. So I'm going to do negative x minus 6. So I took out y and put this in, equals x minus 4. I'm going to add x to both sides. It cancels on this side, so now I have negative 6 equals, what's x plus x? 2x minus 4. What would I do now? What's your next step in getting x by itself? Add 4 to both sides. This cancels. What's negative 6 plus 4? Negative 2, right? So negative 2 equals 2x. Last step is to divide by what? Positive 2, because you want to get this positive 2 away from x. So I get negative 1 equals x. Plug it in right here. Y equals negative 1 minus 4. So if I go back 1 and then I go back 4 more, where am I at? Perfect. So my answer would be negative 1 comma negative 5. Put a box around it. Okay, turn to the next page. Cross through 8, cross through 9. I want you to try number 10. Cross through 8 and 9, try number 10. Okay, so equal bar plus my x's do eliminate because the 5 and negative 5 go to 0. 4y's minus 2y's gives me 2y's. Negative 7 and 1 gives me negative 6. How do you get y by itself at that point? Yeah, divide by 2 on both sides. Y equals negative 3. What do I do to get x? Yeah, put the negative 3 in. Doesn't matter which one I put it into. You'll get the same answer. I'm going to put it into the top. If you put it into the bottom and did the math correct, you should get the same answer. So I'm going to do 5x plus 4, parentheses, negative 3, because I'm taking out the y and putting in the negative 3, equals negative 7. Distribute that. So I get 5x's minus 12 equals negative 7. I'm going to add 12, that cancels. So I get 5x's equal negative 7 plus 12 is 5. Divide by 5, x equals 1. This point is at 1 comma negative 3. Questions? Okay. Put a star next to 11. Put a star next to 5. So 11, 5, and put a star next to 2. 11, 5, and 2. I need for you to complete 11, 5, and 2 tonight for homework. We have 5 minutes. So some of you may be able to get at least 1 done, maybe 2 done. So go ahead and work for about 5 minutes, and then we'll start cleaning up. So 2, 5, and 11, okay?